Hey guys, Oric here. Another video. This one is on the practice test for Advanced Algebra Unit 11. It was at one time called Unit 9 and it's Chapter 11 out of the book, but I've just been referring to it as Unit 11. And I'm going to go through this and please let me know if I make any mistakes on this. I think I've got this worked out, but I just changed a couple of problems around, so some of them I've worked through fairly quickly. So along with the video, I'm gonna reference this formula sheet that I handed out in class. So if I say you use formula number 1, it's referring to arithmetic sequence. The sum of an arithmetic series would be formula number 2. Number 3 is geometric sequence, geometric series, and number 5 is a sum of an infinite geometric series. And on that note sheet I handed out, I do have make some just some notes on recursive sequences as well. So I may refer to the, well, I will be referring to this note sheet, so you may want to have this with you. And I also posted it up on Google Classroom. So let's get started. The first question is just list the first 5 terms of the sequence. This is an arithmetic sequence, so you'd use formula number 1. But basically A1 is the first term, and so in other words 1 is A, so AN, N is 1, just plug 1 in for N. So A1 is 3 times 1 plus 1, which equals 3 plus 1, which is 4. And A2, plug 2 in for N, is equal to 3 times 2 plus 1. So I'm just plugging 2 in for N plus 1. 3 times 2 plus 1 is 6 plus 1, which equals 7. A3 is 3 times 3 plus 1. 3 times 3 plus 1 is 9 plus 1, which equals 10. And as you can see as we go along here, I'm just adding 3 every single time. So my 5 terms, I could keep plugging in for term number 4 and term number 5, but I can see the pattern now. The first number is 4. Sorry, I wrote down 1 there. So the first number is 4. The second term is 7. Third term is 10. Fourth term will be add 3 to it. D is 3 in this problem. I'm adding 3 every single time, so it's 13 and 16. And if you wanted to check it, if I put 5 in for N for the 5th term, it's 15 plus 1. All right, problem number 2. This is also an arithmetic sequence, so formula number 1 on our note sheet. A1 is 6, D is negative 2. So find the 27th term. So A27, the 27th term, N is 27 in this case, is equal to the formula A1, which is 6, plus N minus 1, which is 27 minus 1. And I'm not going to write that out, I'm just going to write down 26, times a negative 2, D, which is negative 2. And that's negative, that's, I guess I could say 6 plus a negative 52, or 6 minus 52 is my 27th term. So basically what I'm doing is, so my final answer is negative 46 is the 27th term. Basically what I'm doing, I'm subtracting 2 every time, so the second term is 4, third term is 2, then 0, then negative 2, negative 4, negative 6, negative 8, until I get to negative 46. Question number 3. This was asking which of all these sequences here, A, B, C, or D, which one is arithmetic? So in other words, which one am I adding the same number every time? So I'll go through these four sequences and let you know what kind of a sequence it is. On this first one, I'm multiplying by 3, then I'm multiplying by 3, then I'm multiplying by 3. So this is a geometric series, or a geometric sequence. This one, if you notice, I've got 3 and then 4, and then 12 is 3 times 4, and then 48 is 4 times 12. This is a recursive, I may not spell that right, and it would actually be of the form an equals a to the n minus 2, 2 terms before it, times a to the n minus 1. And I'd have to say a1 is equal to 3, a2 is equal to 4, and give you that as part of the sequence, and then this is the recursive formula. This one I'm adding 4 every time. D equals 4, I'm adding 4 every time. Sorry, I had to pause my video there for a second, so there might be a little hiccup there. But if you notice, I'm adding 4, adding 4, adding 4, adding 4. So this is an arithmetic sequence. And so the answer to question number 3 is C. And this next one would be another recursive. You got 5 plus 5 equals 10, 10 plus 5 equals 15, 10 plus 15 equals 25. So the next term in the sequence is based off of, usually it's the one term before it, but in these B and D, they were the 2 terms before it. So you would be given A1 and A2, and then something like this, a to the n minus 2 times a to the n minus 1. This one would be a to the n minus 2 plus a to the n minus 1. All right, question number 4. Write a rule, so arithmetic sequence. Right there, we can tell that this is a going to be formula number 1. And I think this question, yeah, the question that's like this on the test is actually, I took it off and made it a bonus question. We didn't work too many problems where we weren't given A1. But if you think about it, this sequence is, there's a first term, A1, A2 is 10, and then we're adding 2. So A3 would be 12, adding 2, so it'd be 12, and then that'd be A2, or that'd be A3, then 14, 16, and so on. A1 is going to be 2, you're going to subtract 2 from it. So A1 is going to be equal to 8, and you have D. So the formula is just a to the an equals A1, formula number 1, which is 8, plus n minus 1 times D, which is 2. And if you leave your answer just like this is a fine answer. When we use sigma notation, or to be a little more specific for an explicit formula, you should work this out, 8 plus 2n minus 2. So 8 minus 2 is 6, so it would be 2n, well, I should write it like this. an equals 2n plus, laughing at my 2 there, it looks kind of mouse written. All right, number 5, write a rule for the geometric sequence, and this one was, I switched this problem around as well. So I had it worked out. Well, this is a geometric sequence, so that's going to be formula number 3 on my formula sheet. Geometric sequence, A1 times r to the n minus 1 power. And the trick is to find r in this. And if you notice on the top, I am multiplying by 1. It always stays 5. It's 5 over 1, 5, 5, 5, 5. So in the numerator, I'm going to be multiplying by 1. In the denominator, I'm multiplying by 3, multiplying by 3, multiplying by 3. So r is equal to 1/3. That's the tricky part of this one. That's why I moved it to the practice test. On the test, it's not a fraction for my geometric sequence. A1 is equal to 5. So the general formula is AN. I could just write this up here in the answer key. AN is equal to A1, which is 5, times R, which is 1/3. So even though geometric sequences in ways are harder, really writing out the formula is there's really not that much to it. N minus 1. A1 R to the N minus 1 power. Why is it N minus 1? Well, if I put 1 in there for N for A1, that becomes 0. It's 1/3 to the 0 power, which is 1. 5 times 1 is just 5. And so the first term ends up being A1 just is this term out in front. All right, number 6. Another geometric sequence. So we got formula number 3. And I would really encourage you on the test to do this. Just what am I looking at? Am I looking at a geometric, arithmetic, sequence, or series? Am I adding numbers every time, or am I just looking for a certain term number? So it's going to be formula number 3, geometric sequence. First term, A1 is 4, common ratio is 3. Find the fourth term. Well, two ways to do this. A4 is equal to A1, which is 4, plus N minus 1, fourth term, so N is equal to 4. N minus 1 would be 3, 4 minus 1. And D is equal to 3. R is equal to 3. Oh wait, geometric. I wish I could erase and rewind. See, I tell you to use geometric, and then I use arithmetic. So AN is equal to A1, which is 4. R is 3. You know, notice how I noticed that when I said R. When I saw that R, then I don't have a D. It's common ratio. I'm multiplying by 3 every time. 4 times 3 to the N minus 1 power, fourth term, so third power. 4 times 3 to the third. Oops. 4 times 3 to the third. 108. 108. Now, fourth term, the other way to do this would be A1 is 4, A2 multiplying by 3 every time. It goes 4, 12, multiplying by 3, 36 is the third term. Multiply by 3, and I get 108. That's the fourth term. All right, number 7. Write a rule for the geometric sequence, so formula number 3 again. I'll try to stick with that this time. A1R, I could probably get rid of one of these, it's the same kind of thing. AN equals A1, which is 6, times R, which is 3, to the N minus 1. So, pretty straightforward if you just use the right formula. All right, number 8. What is the fourth term of the sequence? And now here we're getting into that recursive thing. And you may want to look at your notes here. Here's the note sheet. Recursive A1 is always given. Sometimes A1 and A2 are given. and then a to the n minus 1 means the term before it. So you use the previous term and add 2. Use the previous term and add 2 in this example. In this one, a1 is equal to negative 2. a2 is equal to the term before it, which is negative 2. That's a to the n minus 1 plus 5. And there's no way to quick plug in the fourth term. That's what kind of is a drag about recursive formulas. You got to just go do one at a time until you find the regular rule that's happening. So we got 5 minus 2, we have 3. And then a3, we have the term before it, which is 3 now. We use a2, 3 plus 5. a2 is 3 plus 5 is 8. And a4 is equal to the term before it, which is 8 plus 5. So our answer is 13. All right, question number 9. Now here, fairly tricky, or sure looks tricky, but if you notice 2 times 3 is equal to 6, 3 times 6 is equal to 18, 6 times 18 is 108. So we're taking the two terms, multiplying them together. But I couldn't do that unless I know the first two terms in the sequence. I can't multiply two terms together if I don't know what they are. So I need the first term is 2, and all of these answers, A, B, C, and D, all have 2 as the first term. Most of them give you the second term. This would just be 2 plus 1, which is 3, 4, 5, 6. So it's definitely not A. So they give us the first two terms, and I'm multiplying the two terms together, and that's the next term. And that's looks like what it is. These are, you're adding the two terms together, so the next term would be 5. And you can see these can get kind of complicated. If I multiply the first two together and multiply it by 2, that'd be 4 plus, or a to the n minus 1, there's a term before it, so that a3 on this one, if they give me a2, it would be 2 times a to the n minus 1, so 2 times the term before it, which is a2, 2 times 3, and then plus 2 terms before it, which is a1, which is 2. 6 plus 2 is equal to 8. And so that's not it. They're not getting added together, so it's not it. So the answer is B. More importantly with this one is understanding what this an minus 1 means and an minus 2 means. And then also that in a recursive, at least a1 has to be given. All right, let's keep rolling here. Question number 10, what is the 20th term of the series? Let's see, I'm adding 12, I'm adding 12, I'm adding 12. So I have an arithmetic series. Well, what is the 20th term? That's an arithmetic sequence. Oh, sorry, my alarm clock just went off. So I'm going to end up using formula number 1 to find the 20th term. And then I'm going to use formula number 2 to find the sum of all those. Formula number 1 and formula number 2. So formula number 1 is A20. AN equals A is A1 plus N minus 1 times D. So A20 is equal to A1, which is 2, plus N minus 1. N is 20 in this case. So 19 times D, which I'm adding 12. So D is equal to 12. Arithmetic, you find D. Geometric, you find R. And so we will add this up. 2 times 19 times 12. 2 plus 19 times 12. I had done this, I was looking at my notes here and I think I did that wrong the first time. So let's calculate this out. Hopefully I'm not doing it wrong this time. 2 plus 19 times 12. 230. Now, PEMDAS, it's going to do the 19 times 12 first, and then it's going to add 2, and that's what we want. 230, that's the 20th term. So A20 is 230. The sum of the first 20 terms is equal to n, which is 20, A1, which is 2, plus an, which in this case we're doing A20, is 230, which we just figured out. That's why we have 2 different formulas that we use, all divided by 2. And if you notice, I could reduce this fraction down. 20 over 2 is 10. So I have 232 times 10. And you can do that on your calculator if you want, but hopefully you can know 232 times 10 is 2320. All right, question number 11. What's the sum of the first 10 terms of the series? So it doesn't tell if it's arithmetic or geometric. It's a series, so we know we're adding every time. I'm adding 8, then I'm not adding 8. So it's not arithmetic. I'm multiplying by 3, I'm multiplying by 3, I'm multiplying by 3. So it's a geometric series. R is equal to 3. I'm adding it up, so I'm using formula number 4. And the sum formula for is just, let me just make sure. I think it's 1 minus, let's see, S10 is equal to A1, which is 4, times 1 minus R, which is 3, to the 10th power. Get confused sometimes because it's easy to go 9th power, because some of the geometric has n minus 1 when you use the sequence, all over 1 minus R, which is 1 minus 3. And let's just double check that. Formula number 4, 1 minus R to the n, 1 minus R. A1 is 4. Now be careful on your calculator. Do it in stages. I have 1, let's clear this out. 1 minus 3 to the 10th power. I'm going to get a pretty big number. There's my numerator. I'm going to divide 1 minus 3, so I'm going to divide by negative 2. I'm at 29,000, then I have to multiply by 4. So when I hit times, that's going to put my answer, this 29,000, in there, and multiply by 4. 118,096. 8,096. All right, number 12. Sum of the series. So I'm dividing, the top stays at 1. It's negative because I'm going every other time. I'm basically multiplying by a half. If you notice the denominator, this is 1. I'm multiplying the denominator by 2, the denominator by 2, the denominator by 2. So it's a geometric series, and it's this dot 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 is an infinite geometric series. One of the easier formulas, since the absolute value of R is less than 1, we're just talking about 1/2, this will actually add up to a number, and my formula is A1, which is the first term, which is 3, divided by 1 minus R, which is a negative 1/2. so that's going to be equal to 3 divided by 1 1/2, or 1.5. 3 divided by 1.5 is 2. All right, number 13. Now I know this video is getting a little bit long. I'm at 25 minutes already, so I'm going to try to speed things up here a little bit. How would we write this one? This is our first term. Now we have 5 numbers in this series. The sigma notation means add them all up. There's 5 numbers, 1 through 5, 0 through 5, 1 through 5. This is 1 through infinity. It can't be that. That's for an infinite series, and that's not going to add up to anything. The number is just going to keep going on and on. And if I look at this one, 0 to 5, that's actually 6 terms. We have 5 terms here, so it can't be that one. Now I put I as 1 into this equation. You might be able to tell right now that the answer is D. But if you didn't, you just put 1 in for I, for A1. A1 equals 6 to the first power plus 1, which equals 7. Down here, I have 6 times 1 plus 1, which equals 7. So A1 for these first 2 are both equal to 7. Now A2 is equal to 6 times 2, which is 12, plus 1 is 13. There we go. And over here, A2 is 6 to the second power plus 1. 36 plus 1, 37. So it's not A either. So my answer is D. And if I did the 5th term, I'm going to have 6 times 5 is 30, plus 1 is 31. And there we go. Evaluate. So we have A1. Now this is going to be an arithmetic series. A1 is equal to 2 times 1 plus 3 is 5. A8, you could just do this 1 through 8 and add them all up. A8 is 2 times 8, which is 16, plus 3 is 19. And then our sum formula is formula number 2 on my note sheet. And the formula is n, which is 8. My sum is equal to 8 times A1, which is 5, plus AN, which is A8 in this case, 19 divided by 2. And if I add that up, it adds up to 96. So basically, my first term is going to be 2 plus 3, which is 5. And second term is going to be 4 plus 3 is 7. 5 plus 7 all the way up to plus 19. I get up to 96. Number 15. Now this is a geometric sequence, series, because we're adding. That's what this sum means. So it's going to be formula number 4. And A1 is the first term, R is the second, and what's getting raised to the exponent. So A1 is 2. R is equal to 3, and we're adding up the first 6 terms. N is equal to 6. So formula number 4, we have the sum here of our first 6 terms is A1, which is 2, 1 minus R, which is 3 to the 6th power, all over 1 minus 3. And once again, be careful to do this on the calculator. I worked this out and I got 720 when I did it. All right, and the last one, and it's writing a recursive rule. So we're going to have to know what A1 is. And if you notice, all I'm doing is adding 2 every single time. So if I write the formula as A1 equals 3, A1 equals 3, I'll just write it over here. And then AN is equal to the term before it, A to the N minus 1, which in this case would be 3, and then I'm going to add 2 to it. So my next term is going to be 5. The term after that's going to be 5 plus 2, which is 7. And that's how you write it in recursive form. And that's the end of the practice test. There's 2 or 3 of those problems that I just did that are actually going to be bonus questions on the test. So it's going to be a little bit shorter. All right, take it easy. Have a good one. Bye.